So, taking a look, guys, it says that while Athena was comparing the expression shown at the right, she was called out of the classroom. When her teammates needed help, they looked at her paper and saw the work shown below. Unfortunately, she had forgotten to explain her simplification steps. Can you help them figure out what Athena did to get each new set of expressions? Now, if we take a look, we see that she has her original expressions written down in this first row, with the explanation being original expressions. So we're going to start at this next step, and if we take a look at the difference between our top cell and our bottom cell in this little table, it looks like we're missing our x squared, so she got rid of them. So if you see that there's an x squared on either side, they could cancel each other out, right? It's pretty well balanced. If I had it set so left expression equals right expression, I could subtract x squared from both sides. But since those are both there, I'm going to go ahead and scribble them out, because both sides have it, so both sides are balanced. Next thing's next. Now that we write down that the explanation is subtract x squared from both sides, we take a look at the next difference, and I went from 3x plus 4 minus x minus negative 2 to 3x plus 4 minus x plus 2. But nothing changed between our right expression. So our right expression changed the same, but on the left side it looks like we took these negative ones and we brought them up top to become positive. The reason being is if we have a negative times negative 2, it can become a positive 2 that we see down below. Next thing's next. When we write down the explanation, we're going to say that we distributed the negative. We see that we went from 3x plus 4 minus x plus 2 in our left expression, and it wound up becoming 2x plus 6. So I know that 3x minus x gives me 2x, and then I know that 4 plus 2 gives me 6. So it looks like I combined like terms. But did I do it on the right side as well? Let's take a look. I've got 4x minus 2x, which does equal 2x. And I have negative 1 minus 4 is negative 5. So it looks like we did, in fact, combine like terms. Then, what we see here is we had 6 and we had negative 5. If we're going to go over into our E tool and take a look, we've put these up top, and then we combined our like terms. So we had our 3x minus x. So these two canceled each other out on the left side. On the right side, these two cancel each other out. And then over here, having negative 1 and negative 4, all of these came up top and became negative. So now I should have nothing in the bottom worthy of looking at. In either side, I have specific tiles that are already canceled out. And on our top, we just have our 2x plus 1, 2, 3, 4, 5, 6, and our 2x minus 1, 2, 3, 4, 5. And if we take a look at our last step, it looks like we subtracted 2x from both sides, because if you look at our E tool, we have 2 x's on both sides of the equation. So if we were to see and pretend that they were on a scale, they both have that weight of the 2x. So if we subtract 2x from both sides, we wind up with just the constants, and we wind up having 6 minus 5, because we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, negative 5 on the right. So we subtract 2x from both sides, and we see that the left equation, or the left expression, has a value of 6. The right expression has a value of negative 5, so we would say that because 6 is greater than negative 5, the left expression is greater than the right. So, if, while Athena was comparing the expressions shown at the right, and we're taking a look at specifically the E tool that has those things displayed. When we take a look at the steps she made, I'm going to show you the way that the moves worked within the tool. So from the first cell to the second cell, it looks like they had subtracted x squared from both sides. So we can click and take them out. Next thing's next. It looks like we distributed the negative for our -2. So you see the -2 here? Well, the two negative ones. If you tap and drag, the -2 became a +2. Next, we didn't do anything to the right side just yet, but now we combined like terms. And so what we did is we combined all of our x's and all of our 1's on the left side and on the right side to make sure that everything is up in the positive section. So the way to do that is we have 3x in the top, and we have a negative x, or a positive x on that negative side, which we know is a negative x. So if we bring it up to the top, that's a negative x, which means that we gotta take this 2 pair out because they cancel each other out. And we know that 1, 2 plus 4 is 6. So on our left side, we know that we just have 2x plus 6. But on the right side, if we're going to combine like terms, if I'm going to have this x in the negative side, I bring it up, and it's a negative x. So I take that pair out. I bring this x up as well. It's a negative x. So I can take that pair out. And then I've got a -1, -2, -3, -4 to take up top. So then on my right side, I know I have I have 2x minus 5. So now that I know that I have 2x minus 5, I see that I have 2 x's on my left and 2 x's on my right. So I could take them both out because x would hold the same value no matter what x was. And I see on my left I have +6, on my right I have -5, and +6 will always be greater than -5. So that's how you would use the E tool to do the exact same work that we just wrote out, drawing around on the expression map in Notability for me, but could have been on your notes for you. But that's how we did the legal moves to solve to determine which is greater or which side is greater. And this is what you guys are going to do in the next couple of slides.